Hello, myself Mohan Ji. In this video, I am going to explain you about Pascal's law. Pascal's law states that pressure or intensity of pressure at a point in a static fluid is equal in all directions. That is, we have to prove that Px is equal to Py is equal to Pz, where Px, Py, Pz are the pressure acting on a static fluid which is equal in all direction. In order to prove that, I am going to consider one fluid element of wedge shape of very small dimension of dx, dy and ds. Let Px is the pressure or intensity of the pressure acting on face AB, and Py is the pressure acting on face AC. Let Pz be the pressure or intensity of the pressure acting on face BC. Now let me calculate the pressure forces acting on face AB and face AC and face BC. Now pressure force on face AB. We know that pressure is equal to pressure force divided by area. Therefore, pressure force is equal to pressure into area, correct? Therefore, pressure force acting on face AB is pressure into area. Pressure acting on face AB is Px and area of the face AB is dy into 1, because I'm going to assume the width of this element as unity. Therefore, the area is dy into 1. Therefore, the pressure acting on face AB is Px into dy. This is acting like this. This is Px into dy. Now similarly, pressure force on face AC. Pressure force on face AC is given by again pressure into area. Pressure acting on face AC is Py, and area of face AC is dx into 1. Therefore, pressure force on face AC is Py into dx. This is acting like this. This is Py into dx. Similarly, pressure force on face BC. The formula is again pressure acting on BC into area of BC. Pressure acting on BC is Pz and area is ds into 1. Therefore, pressure force acting on BC is Pz into ds. Pz into ds. Now let this angle be theta. Therefore, this angle also will be theta. Now let me resolve this Pz ds in both horizontal and vertical direction. If I resolve this Pz into ds in horizontal direction, we will get Pz ds cos theta, and if we resolve that force in vertical direction, we will get Pz ds sin theta. Correct. Now what are the forces acting on this fluid element? One is pressure force on face AB, face BC and face AC, and weight of the element. These are the two forces which are acting on this fluid element. Now let me resolve the forces horizontally. Now resolve the forces horizontally. What are the forces acting horizontally? One is Px into dy, another one is Pz ds cos theta. Px dy, correct, minus Pz ds cos theta. Is there any other horizontal forces? No, only two horizontal forces are there. Therefore, I am going to take Px into dy minus Pz into ds into cos theta, which is equal to 0. Now, from the figure, what is cos theta? Cos theta is equal to adjacent by hypotenuse. Adjacent is AB. Adjacent is AB. Hypotenuse is BC. Okay, now cos theta is equal to, what is adjacent? Adjacent AB is dy. BC is ds. Yes, now ds into cos theta. ds into cos theta can be written as dy. Therefore, Px into dy minus Pz as it is ds into cos theta. ds into cos theta can be replaced with dy. dy is equal to 0. Now, Px into dy is equal to Pz into dy. dy get cancelled. The remaining will be Px is equal to Pz. This is one equation. Equation number 1. Now, similarly, resolve the forces vertically. Resolve the forces vertically. Here the sign convention is I am going to take upward force as positive, downward force as negative. Here right side force as positive and left side force as negative. It's your wish, you can take vice versa also. Now resolve the forces vertically. What are the forces acting vertically? One is Py into dx. This is acting upward. The second one is Pz into ds into sin theta, which is acting downward, and weight of the element. Weight of the element which always acts downward. Now write that Py into dx upward force minus Pz ds sin theta, which is acting downwards, minus again weight of the element which is acting downward, is equal to 0. Now from the figure, what is sin theta? Sin theta is opposite by hypotenuse. Opposite is AC, hypotenuse is BC. Now sin theta is equal to, what is AC? AC can be written as dx, BC can be written as ds. Therefore, ds into sin theta is equal to dx. Now Py into dx minus Pz as it is, ds into sin theta. ds into sin theta can be replaced with dx minus weight. What is weight formula? We know that density is equal to mass by volume. Density is equal to mass by volume. Density is equal to mass by volume. Weight can be written as m into g. Weight can be written as m into g. Now weight is equal to mass. Mass can be written as density into volume into g. Density into volume into g minus density into volume of the fluid element into g is equal to 0. Now Py dx minus Pz dx minus rho. Let rho is the density of the fluid element. Now what is volume? Volume is area into length. Since this is of triangular shape, therefore the area will be half into base into height. Half into base. Base is AC. AC can be written as dx. dx into height. Height is AB. AB can be written as dy into height. As I said, if we assume the width of the fluid element as 1, therefore into 1 into g is equal to 0. And this dx and dy are very small, therefore we are going to neglect this term, full weight term. Then the remaining equations will be Py into dx minus Pz into dx is equal to 0. Now Py into dx is equal to Pz into dx. Now dx get cancels. The remaining term will be Py is equal to Pz. This is equation number 2. Now combine equation 1 and equation 2. What is equation 1? Equation 1 is Px is equal to Pz and equation 2 is Py is equal to Pz. From equation 1 and equation 2 we can written as Px is equal to Py is equal to Pz. Px is equal to Py is equal to Pz from equation 1 and equation 2. Hence it is proved that pressure or intensity of the pressure at a point in a static fluid is equal in all direction, that is Px is equal to Py is equal to Pz. Thank you.